Okay, our final page, the trig part of our story. So off we go. I don't totally feel like this page is as thorough as I wish it were because there's some pieces on the test that it doesn't fully grasp, but hopefully I'll take care of that down here. So please don't forget that when we talk in this other form where you had something like 3 plus 3i, remember this looks almost like 3 comma 3, but it's not. So remember when you find your radius, you're going to go 3 roots of 2, and then you have to find that angle. So you should be able to convert back and forth between the a plus bi form and that r cis theta form, okay? So when we deal with De Moivre's theorem and all this stuff, the first thing to be aware of is that when you multiply values z1 and z2, what we're supposed to do is we're supposed to take the product of the radii, which would be 72, and then we're supposed to then add those angles together. Now, as it turns out, 75 and 15 do make, in fact, 90 degrees, which is a nice, easy value. Now, you'll notice I said just leave it alone, but then over here it says, let's go ahead and convert that. So remember 90 degrees would be sitting right up here at the coordinate 0 plus 1i. Remember, cis notation, it's the cosine of 90, which is 0, and the sine of 90, which is 1. So if we were converting that, we'd get 72 times 1, like 0 plus 1i, or in other words, 72i, and we'd be done, okay? Now, when we divide, it's a little bit different because we're then going to divide those radii. And of course, 12 divided by 6 is 2. And then we go ahead and subtract those angles, and 75 minus 15 is 60 degrees. Now, it does say to go one step further, but remember that the cosine of 60 degrees is just pi over 3. The cosine of any kind of pi over 3 is a half, and the sine would be root 3 over 2. But since 60 degrees is in the first quadrant, it should be to the right and up, or in other words, 1 plus root 3i. This is the little piece that I wanted to make sure we were good at, is converting something like this into this format right here. That's something that was not explicitly done in here. And so going a little bit further, when we look at number 23, and we're going to use De Moivre's theorem, I don't want to do 2 minus 2i 6 times and multiply that out. That's just a pain in the butt. I just don't want to go there. So what I'm going to do instead is I'm going to start by saying, well, 2 minus 2i is going to have then a modulus, fancy word for radius, of 2 roots of 2. And that's going to be at the angle negative pi over 4. So the first thing I like to do is get it into the proper form. So that's the value that I had for 2 minus 2i, but then I want to take this thing and raise it to the 6th power. Well, De Moivre's theorem says take the radius and raise it to that power, and then take the angle and multiply it by that value as well. Now, I wrote it as negative 6 pi over 4, but remember that is in fact negative 3 pi over 2. And again, if you have trouble with dealing with all these roots, it's not that big of a deal. So we had 2 roots of 2, but we're going to raise that to the 6th power, and it's a pretty nice number. It's 512. And last but not least, we have 512, cis, and accidentally made a weird little note there. Negative 3 pi over 2, which negative 3 pi over 2 is actually right up here, which is the coordinate again, 0 plus 1i. So this is 512, and the cis part is 0 plus 1i, or 512i. Now, again, it would be silly not to utilize our calculator to double check that. Let's see. What is 2 minus 2i raised to the 6th power? And there we go. We got 512i, which confirms it. Now, I did make this one a little bit nicer. To the right 3 and down 4 makes a radius of 5. So my story is 5 CIS. Now, I'm going to go ahead and grab my little RP theta guy and say, hey, calculator, help me out with going to the right 3 and down 4. Now, it told me I had this weird angle right here, negative 0.927. So if I raise it to the 4th, I'm going to have 5 to the 4th CIS, and I need to multiply that angle by 5. But what I like to do is I like to store that as some value like A or something like that. And so what I need to do now is I need to take 5 to the 4th times the cosine of A, and my calculator gives me, I got something weird happening right here. So let me try that again. So I have 3 minus 4. So let me go to my angle. I don't want to start the whole video over because something weird just happened. So there's my angle times by the number 4. Oh, that's why I hit the wrong times by. That's negative 3.709. Now I got it. So what I'm going to do, let's store that again as A. And so now I'm going to take 5 raised to the 4th times the cosine of that angle. Whatever that angle is, that angle 3.709. And I got negative 527. And if I try it again, but instead of taking the cosine, and I took the sine part, that'd be plus 336 pi. And that's the power of De Moivre's theorem, is we can very quickly get some good stuff. Okay, finishing this up, we're going to find the 4th roots of negative 81 and the cube roots of negative 8. I kind of wish I didn't make these both negative 81 or negative 8. I wish one of them had an I in it, but it starts the same way. Negative 81 is 81 units straight to the left. Here, negative 8 is 8 units directly again to the left. But if I'm going to take the 4th roots of it, I'm going to raise it to the 1/4 power, and the 1/4 power of 81 is 3, and I multiply by 1/4, and I get pi over 4. This is my first answer, which is, in other words, root 2 over 2 plus root 2 over 2 pi, because the cosine and sine of any kind of pi over 4 is root 2 over 2. But the beautiful thing is if you're looking for 4th roots, there's going to be an answer exactly every 2 pi over 4. And the 2 pi comes from the full circle. The 4 comes from dividing that 2 pi into 4 equal pieces. In the same way, this one is going to be 2 pi cut into 3 perfectly equal pieces. So if my first answer is here, my next answer is going to be at 3 pi over 4, 5 pi over 4, and 7 pi over 4. And what's fun about that, or maybe not fun, depending on your perspective, is the cosine and the sine of any kind of pi over 4 is always going to be root 2 over 2 every single time. It's just that's in the first quadrant, which is to the right and up. This one is to the left and up. This one is to the left and down. And this one is to the right and down. And we have all 4 different renditions of pluses and minuses. And then the last one right here is if we take z to the 1/3, 8 to the 1/3 is 2. We take this pi times 1/3, it's pi over 3. That's my first answer. My next answer, I need to rotate forward. Just here I rotated 2 pi over 4. Here I'm going to rotate 2 pi over 3. So that would be pi, or 3 pi over 3. And 3 pi over 3 plus that is 5 pi over 3. So here are my 1, 2, 3 answers. First answer, of course, is going to be cosine of pi over 3 is a half. Sine is root 3 over 2. The cosine of pi is -1, and the sine is 0. So these are all my a plus bi version values. And my last one is 5 pi over 3, which is to the right and down. And you should notice that these two are conjugates of each other. Now, depending on how you want to do it, a lot of people will leave it this way, and some people would want to distribute that too and produce answers like 1 plus root 3i, -2 even, and 1 minus root 3i. These are probably a little easier answers to understand. But remember, when you're taking your test, if you got this answer and you're not sure if it's right, it would be very easy to take that value, and again, if this is supposed to be a cube root of -8, if I cube this value, I should get -8. And in fact, I got -8 plus no i's. And checking the other one is very, very easy because it's just the conjugate and it also worked. And -2, of course, -2 cubed is pretty obviously going to be -8. So there we go. We finished. All right. We'll see you back in class. Bye-bye.